Okay, so up until now, we've been talking about theoretical probability. What I'm going to introduce to you is relative frequency and experimental probability. So just to recap theoretical probability, this is based on mass. So as an example, if I roll a fair dice, what is the probability of getting a 6? I know that there are 6 possibilities or 6 outcomes when I roll the dice, and 6 is just one of these. So it is one outcome out of a possible 6. That is for theoretical. For experimental probability, as the name suggests, it's based upon experiment. So this is where I carry out some experiments and I observe the results, and I calculate a probability based upon that. So here it says, if I roll a dice 100 times, I get 50 6s. So what is the probability of rolling a 6 with this dice? So here I can say that I rolled it 100 times, and 50 of those times, it was a 6. If I simplified that, that's going to give me a half. So half of the time that I roll this dice, I get a 6. The relative frequency, which I'm going to talk about in a second, is this 50 divided by 100. I'm going to explain a bit more detail how we get that in a moment. Before we get there, I just want to recap what fair and bias means. So here with a fair dice, each of these outcomes is equally likely. So the chance of getting a 6 is 1 out of 6. Chance of getting a 3 is 1 out of 6. All of them have the same probability of happening. With this dice, however, after I've carried out the experiment, I found that half the time when I roll it, I get a 6. So I can say for this dice, it is biased, or it's likely to be biased. That's because getting a 6 happens more often than the other possibilities. Okay, so I'm going to go through an example. If I roll a dice 100 times and put results on the table, this is what I get. So the scores, I've got 1 through to 6, and the frequency, so the amount of times each one happens. Well, I want to find the relative frequency of each score. So relative frequency is just the amount of times it happened out of the amount of times it was tried, the total amount of times it was tried. So if I come down to the table here, I'm just going to fill it out. I know that the dice was rolled 100 times, and I'm going to write these just as fractions. So it happened 3 times out of 100 times, and then 14 times out of 100, and then 41 out of 100, and then 20 out of 100, and then 18 out of 100, and then 4 times out of 100. So the relative frequencies for each outcome are shown here. And with these, I can always check that I'm right, because if I add all of these together, they should add up to 1, because the sum of probabilities always add up to 1. So looking at this data, I want to make an assessment of whether the dice is biased or fair. So are the relative frequencies equal or nearly equal, or are they not? So if I look through, the 1 only happened 3 times, the 3 happened 41 times, and the 6 happened 4 times. So I can say that this is probably biased because certain outcomes happen much more frequently than others. Okay, so to continue the example, I've just copied the relative frequencies from the previous slide. It is worth saying at this point that although here I'm representing these relative frequencies as fractions, you could also see them as decimals. So now I'm going to use these relative frequencies to make some estimations about how many outcomes will happen depending on how many trials I carry out. So if I roll the same dice 200 times, I want to estimate how many times I would get 100. So to do this, I'm simply going to do 3 over 100 times by the amount of times it's going to happen. So relative frequency or probability times by 200. So 3 over 100 times 200 is just going to give me 6 times. If I roll the same dice 400 times, I would estimate how many 4s I would get. So again, take my probability or relative frequency, and I'm going to multiply it by the times that I'm going to do it. 400 times. Which is going to give me 144. Sorry, 164. So these are the type of questions you're going to see. Another really important point with these is the more times you do the experiment, the more accurate your estimation of the probability should be. So here I only rolled it 100 times. If I rolled it 200 times, these would be more accurate again. If I rolled them 1,000 times, probabilities would be more accurate still. All right, so one example of an exam question, and I want you to have a go. So here, Marco has a 4-sided spinner, and the sides of the spinner are numbered 1, 2, 3, and 4. And the spinner is biased. So it's telling us straight away that it is biased. First of all, it's given us some probabilities, and it wants us to figure out the probability that the spinner will land on 4. So to do this, we need to recall that all of these probabilities added together are going to equal to 1. So I can add the 3 that I've got and then take that away from 1 to give me the probability of finding 4. So I'm going to do 0.2 plus 0.35 plus another 0.2, which is going to give me 0.75. And then I'm going to do 1, take away 0.75, which is going to give me 0.25. So the chance of rolling a 4 is 0.25. Second part says, Marco spins the spinner 100 times. Work out an estimate for the number of times the spinner will land on 2. So know the probability of landing on 2. Already you can see it is 0.35. Now I'm going to multiply that by 100. Which is going to give me 35 times. And that's it. What I'd like you to do next is have a go at the Google's form worksheet, which will be in the comment for this video. I've also posted it on Edmodo. What that does, it automatically gives me feedback of what you've done. So there's some multiple choice answers and there's some short worded answers that you need to give there. So please complete that as soon as you can. I will be posting solutions and feedback to you over the next few days.